Hi children, welcome back to the online classes. This is the third session of the chapter motion. In the previous session we have discussed about average speed, average velocity, instantaneous speed and instantaneous velocity. So, how can we get the direction of the instantaneous velocity? So, if this is the path you have taken, if you want the direction of velocity, instantaneous velocity at this point, you need to draw a tangent at this point. The tangent will give direction of velocity. The tangent will give direction of velocity. What is meant by tangent? Tangent is a line which intersects the curve. This is the curve at single point. Tangent is the line which intersects the curve at single point. So, the tangent direction, the instantaneous velocity will be along the direction of the tangent. Instantaneous velocity will be along the direction of the tangent. So, let us learn about the uniform motion. So, let us discuss with an example. So, here you have stopwatch and you need to calculate the time and distance travel or displacement. You are traveling on a straight road. If you are traveling on a straight road, the distance and displacement are equal. If you are traveling on a straight line way, in a straight line way you are traveling, if you are traveling in a straight line, the distance and displacement are equal. Both distance and displacement are equal. Let us assume that you are traveling on a straight way. So, the stopwatch is showing 0. So, here T1 is equal to 0 seconds. The stopwatch is still not showing. So, you are also at starting position. You are starting with some vehicle here. So, you are along with the vehicle. You are at the starting position. So, at 0 seconds you doesn't travel any distance. So, this distance traveled is 0. After 1 second, so let us say at 0 seconds your distance traveled is 0 and time starts now. After 1 second, the distance traveled is 4 meters. You have traveled a distance of 4 meters. That means your position now here. Your position is here. You have traveled a distance of 4 meters. And after 2 seconds, your distance traveled is 8 meters. Now, that means after 2 seconds you are here. So, initially 0 seconds you are at initial position, the distance traveled is 0. After 1 second, this is the position. How much distance you have covered? 4 meters. After 2 seconds, how much distance you have covered? 4 plus 4, 8 meters of distance. After 3 seconds, your distance covered is 12 meters. That means you have covered one more 4 meters of distance. So, this is your position at after 3 seconds. So, how much total distance you have covered? So, this is the starting position. From starting to ending you have covered a distance of 12 meters. You have covered a distance of 12 meters. So, here uniform motion, such a motion is called as uniform motion. What you have observed here, the distance travel, the object travels equal distances 4 meters in 1 second of time gap. This is what is the time gap? 1 second. How much distance is travelled? 4 meters. What is the time gap? 1 second. How much distance you have travelled? 4 meters. What is the time gap? 1 second. How much distance you have travelled in the time gap? 4 meters. Here, if body covers equal distances in equal intervals of time, interval means time gap. So, for a equal time interval, you are covering equal distances. For 1 second of time, for every 1 second, you are covering 4 meters, and for the next 1 second, you have covered a distance of 4 meters, and for the next 1 second, you have covered a distance of 4 meters. So, here you are covering equal distances in equal intervals of time. You are covering equal distance. So, in the first second you have covered 4 meters, this is equal to this one, right, and this 4 meters is equal to this 4 meters. You are covering equal distances in equal intervals of time. So, such motion is called as uniform motion. So, here what is your velocity? 4 meters per second. Your velocity is 4 meters per second. Your velocity is 4 meters per second towards east. So, here in this position also your velocity 4 meters per second. After the velocity, after your velocity is also 4 meters per second. Here the magnitude 4 meters per second is not varying. Your speed is same, your velocity is same, and your direction is also not changing. Your direction is also not changing, and hence here in uniform motion velocity is constant. Velocity is constant. If the object travels with constant velocity, then that motion is called as uniform motion. The motion in which the velocity is constant is called as uniform motion. If the motion is said to be uniform, if its velocity is constant, you can write it as definition. So, what is the definition? So, uniform motion is nothing but uniform motion is nothing but if the motion is said to be uniform, if the motion is said to be uniform, if the motion is said to be uniform when its velocity is constant. So, when the velocity of the object is constant, then the motion is called as uniform motion. If the motion is said to be uniform when its velocity is constant. If its velocity is constant, then the motion is said to be uniform. So, how can you know that the velocity is constant? For the speed is 4 meters per second. In 1 second, it is covered a distance of 4 meters, and in the next 1 second, it is covered a distance of 4 meters. So, what was happening? The speed and direction is same. The velocity and direction. Even if the direction changes, it cannot be called as uniform motion. So, let us discuss about non-uniform motion. What is uniform motion? If the velocity of the object is constant, then the motion is said to be uniform motion. Let us discuss about non-uniform motion. Non-uniform motion. In uniform motion, your speed must be same, your speed must be constant, and your direction is also same. If the direction changes, then you can't say that it has a uniform motion. In uniform motion, velocity is constant. What is meant by velocity? It is having some magnitude and direction. If the direction changes, then it cannot be called as uniform velocity. Okay. If the direction of the velocity is changing, then it cannot be called as a uniform motion. So, let us discuss some examples about non-uniform motion. So, let us consider an inclined plane. I have made an arrangement like this. This is an inclined plane, and I released a ball here. What will happen? It will travels along this inclined plane. At 0 seconds, the ball is at this position. After 1 second, the ball is at this position. After 2 seconds, the ball is at this position, 2 seconds. After 3 seconds, this is at here, the ball is at here. So, here for 1 second, the distance travelled is, let us take it as 1 meter. In 1 second of gap, it is travelled a distance of 1 meter. So, in the next 1 second of gap, it is covered a distance of 2 meters. In the next 1 second, it is covered a distance of 3 meters. So, here what was happening? If the distance covered, the distance is unequal for equal intervals of time. The distance covered, if here the object is covering unequal distances in equal intervals of time. For the same 1 second here it is travelled 1 meter. For the same 1 second it is travelled 2 meters. For the same 1 second of time gap it is travelled 3 meters. So, what was happening? In the inclined plane, on a inclined plane, the speed is increasing. Here it is having low speed, and when it reaches to the ground it is having high speed. The velocity is increasing at this position. Here what was happening? Speed is changing, and hence this motion is a non-uniform motion. Uniform means all you are wearing uniform, right? So, to have some same appearance, all must be equal, all must be same, constant. The meaning of the uniform is constant. Uniform motion means same speed, but for an inclined plane, if you release the ball on the inclined plane, the speed is not same. Here the speed is 0, here it is having some value, and here it is having high speed. When it reaches to the ground, it is having high speed. So, here what will happen if the ball is travelling like this, the speed is changing. The speed is changing. Speed changes, and hence this is not a uniform motion. We will call this motion as a non-uniform motion. What do you mean by uniform motion? If the velocity is constant, then the motion is said to be uniform motion. If here speed is changing, so then it is not a uniform motion. We will call this such type of motions as a non-uniform motion. We will call such type of motions as a non-uniform motion. So, let us discuss another example. So, tie a stone to a thread. Tie a stone to a thread. Tie a stone through a thread. I have tied this stone to a thread. So, just whirl it. Whirl means just make some rounds with that stone. Just make some rounds. So, what is the path taken? It will take path like this. The stone will, if I did like this, so what will happen? It will take a circular rounds. Tie a stone to the thread and whirl it. So, what will happen? It takes a circular path. So, let us imagine the stone is moving with same speed. So, constant speed. Let us imagine that the stone is moving with a constant speed. Can you say that this is the uniform motion? It is having same speed. The stone is making rounds with the same speed. I was doing like this. The stone is making rounds with constant speed. Can you say that this is a uniform motion? Here speed is constant. No, you cannot say that it as uniform motion. Of course, it is having same speed. Let us take the speed as 4 meters per second. So, the stone is making rounds with a speed of 4 meters per second. It is making a round of 4 meters per second, its speed. But what was happening? The direction is changing. The direction of the stone is changing. So, if you want the direction of the stone at this point will be given by the tangent in this position. So, let us imagine that the stone is revolving like this. So, this is the direction, and at this position the direction is this one. At this position the direction of the velocity is this one, and at this position the direction of the velocity of the stone is this one. So, in this way what was happening? The velocity direction is changing. And hence this is not a uniform motion. Why? Here velocity is changing. Velocity includes magnitude and direction. So, in the previous example the magnitude is changing. So, and that means in the inclined plane example the magnitude of velocity is changing, but the direction is same only along the inclined plane only. The direction is same, but here the speed is same. But what was happening? The direction is changing. So, the velocity means changing. Here the velocity is not constant, speed is constant. speed is value, speed is the value, speed is constant, that means magnitude is constant, but the direction is changing, and hence this is also a non-uniform motion. What is meant by non-uniform motion? So, here direction changes, so anyone, if speed changes then also it is non-uniform motion, if the direction changes then also it is a non-uniform motion. So, in this example speed is same, direction is changing, in this example direction is same, speed is changing. So, even magnitude or direction is changed, then it is a non-uniform motion, that means velocity changes. If the velocity changes, we can call that motion as non-uniform motion. So, let us discuss an example, which is having both speed and direction will be changes. So, we have discussed two examples. In first example, speed changes, directions remain same. In the second example, speed same, direction is changing. Let us discuss another example which shows both speed and direction is changing. So, let us throw a stone like this. So, the stone will takes a curved path. So, initially when you throw a stone like this, the speed slowly changes and comes to 0 at this point, and again the speed increases and reaches to the ground. Here what was happening? In this way the speed is decreasing, and again from this point the speed again increases. So, here what was happening? Speed is changing. So, if you throw a stone like this, the stone will slows down up to maximum point, and after maximum point the speed again increases. Here what was happening? Speed is changing and the direction is also changing. Here the direction is this one, here the direction is this one, here the direction is in this way. What was happening? Here both speed and direction is changing in this example. So, if speed changes, what does that mean? Velocity is changing. If direction is changing, velocity is changing. So, these are the examples of non-uniform motion. What is meant by non-uniform motion? If the motion is said to be non-uniform when its velocity is changing. If the motion is said to be non-uniform when its velocity is, if the motion of the object is said to be non-uniform when its velocity is changing. When its velocity is changing, we will call its motion as non-uniform motion. So, this is about uniform motion and non-uniform motion. So, let me ask you a question. So, just drop an object like this, So, if you drop an object like this, is the speed of the object is same? Speed varies? Yes, the speed is changing. So, if I release an object like this, what was happening? The speed is changing, the speed is increasing. So, initially when I left, I did not give any velocity to this, I just released this. That means, at this position, the initial speed is 0 meters per second. At this position, the initial speed is 0 meters per second. After 1 second, what is this speed? After 1 second, it attains a speed of 9.8 meters per second. It attains a speed of 9.8 meters per second. So, how this 9.8 meters per second was achieved? So, to know that, we need to know about the acceleration. Acceleration. Acceleration will give how fast the speed is changing. How fast the speed is changing. Acceleration gives how fast the speed is changing. So, it gives, acceleration gives how fast the speed is changing. Acceleration gives how fast the speed is changing. For example, if you want to increase the speed of your vehicle, what you need to do? You have to accelerate. You have to accelerate. So, increasing of speed is called as acceleration. Acceleration is nothing but rate of change of velocity. Rate of change of velocity is called as acceleration. Rate of change of velocity is called as acceleration. Rate of change, rate means we are comparing with time, change of velocity is compared with time. So, the rate of change of velocity is called as acceleration. So, here acceleration is denoted with small a. Small a is equal to change in velocity by time taken. Acceleration can be find out with the formula change in velocity. Delta v means change in velocity. So, v minus u by t. V minus u by t. So, t is the time taken and v is the final velocity and u is the initial velocity. U is the initial velocity and v is the final velocity. So, change means final minus initial. Change means final minus initial. So, this is the formula to find out the acceleration. So, what it will give? How fast the speed is changing. If the velocity is changing, that means you are accelerating. So, if you keep the vehicle like this without acceleration, it will move with same velocity. It will move with same velocity. If you accelerate, its speed will increases. Not only increase of speed is called as acceleration, decrease of speed, decrease of velocity is also called as acceleration. So, whenever you are applying the brakes, what has happened? Velocity decreases. Whenever you are applying the brakes, what has happened? Velocity decreases. So, decrease of velocity is also called as acceleration. Decrease of velocity is also called as acceleration. So, let us discuss an example. For example, I was releasing this object and the acceleration, the earth is having some acceleration, it is applying some force, the acceleration due to gravity, here what was happening? The speed is increasing, at this position speed was different and at this position the speed is different. So, if I stop the object here the speed is different and here the speed is different. So, what was happening? The speed is increasing, the object is accelerating due to gravity of earth. Due to gravity of earth, the object is accelerating. Why? Because its speed is increasing. Its speed is increasing. So, acceleration due to gravity value is acceleration due to gravity. The value is 9.8 meter per second square. The acceleration due to gravity value is 9.8 meter per second square. Let us rewrite that 9.8 meter per second What is the meaning of this? 9 meter per second square is nothing but 9.8 meter per second per second. In 1 second, the speed of the object will increases to 9.8. So, initially the speed of this object is 0. After 1 second, the speed will become 9.8 meters per second. So, how much in 1 second, how much speed is increasing? 9.8 meters per second. So, acceleration due to gravity value is 9.8 meter per second square. That means, in 1 second, the speed will increases to 9.8. So, in the next second, the speed becomes double of this. That means, 19.6 meter per second. And after 3 seconds, the speed becomes, calculate this, 19.6 plus 9.8, how much? 14, 19, 29.4 meters per second, 29.4 meters per second. So, what was happened here? The speed was increasing. How much? At which rate it was increasing? Per second. In 1 second, the speed was increased to 9.8. So, initially 0 and later speed 9.8. Again one more 9.8 was increased. So, in 1 second, how much speed was increasing? 9.8 meters per second of speed was increasing. So, in 1 second its speed. So, here 0, 9.8 meters per second here speed. After 2 seconds the speed is 19.6. After 3 seconds the speed is 29.4. For every second the speed is increasing to 9.8 meters per second. For every second the speed is increases to 9.8 meters per second. So, here in this example the speed is increasing. If you release the object, the speed is increasing. So, if you throw an object in an upward direction, in the downward direction the acceleration is 9.8 meters per second square. If for 1 second your speed is increases to 9.8. So, if you throw an object in the upward direction, this acceleration gravity will be in the opposite direction. So, in this example the object is moving along the gravity direction. What is the direction of the gravity? Earth will pull towards it. What is the meaning of gravity? The force of the earth towards the surface of earth is called gravity. So, the object is moving in the same direction and hence its speed increases. If the object is moving in the upward direction, what will happen? Its speed decreases. For example, I was thrown the object with a velocity of 29.4 meters per second. So, I have thrown this object with some velocity. What is that velocity? 29.4. After 1 second, its velocity becomes 19.6 meters per second. Why? Because the same value acts in the opposite direction. The object is moving upward direction and the acceleration is in the downward direction. So, acceleration value is 9.8 meter per second in second. So, this is same, I was just rewrite this 9 meters per second square is nothing but 9.8 meters per second per second. So, it is in the opposite direction, the speed is decreases for about 9.8 meters per second. What is the difference here? 9.8 meters per second. So, since it is acting in the opposite direction, the speed is what happened? Decreases. So, again this after 1 second the speed becomes 19.6 meters per second. After 2 seconds the speed becomes 9.8 meters per second. After 3 seconds the speed becomes 0. So, at this position if I throw an object like this, at the high position the object velocity is 0 and again it returns back to the ground. So, what was happening? The speed is decreasing because of the opposite direction of acceleration. In this case, this is the same direction. The object is moving in the same direction of gravity. So, here the object is moving opposite direction of the gravity. Hence, here the velocity decreases. So, we need to take a minus sign. You have taken here plus sign. Initially 0, after 9.8 meter per second its speed increases. After again plus 9.8, again plus 9.8. So, in this way the speed is increasing. In this case, when the object is thrown in the upward direction, the speed is decreasing and hence you have to take acceleration as a negative. Why? Because 29.4 minus 9.8 is equal to 19.6. What was happening? Due to opposite direction of the acceleration, the speed is decreasing. This negative sign acceleration is called as deceleration. Negative acceleration is called as deceleration. Acceleration means increasing of speed. Deceleration means decreasing of speed. So, negative acceleration is called deceleration. So, when you release the object like this, it is accelerating. When you throw an object in the upward direction, it is decelerating. Decelerating means its velocity is decreasing. When the object is if you throw an object in the upward direction, the velocity of the object is decreasing. If you release the object, the velocity is increasing. So, increasing of acceleration is, we can call it as acceleration. So, if the direction of the object is opposite to the gravity, it is taken as negative value. So, that negative acceleration is called as deceleration. So, deceleration will decreases the speed. So, whenever you are traveling on a vehicle, you will apply brakes. By applying the brakes, what will happen? The velocity decreases. So, by applying the brake, what you are doing is you are decelerating the vehicle. By accelerating the vehicle, you have an accelerator. So, if you are accelerating, speed will increases. So, to decelerate, you need to apply the brakes. So, brakes will makes the object to decelerate, to make its velocity decreases. So, this is with this the lesson motion is completed. Thank you.